Okay, we're back. Yeah, so yeah, I didn't see the slides. I thought the slides were gonna say something different, but that's okay. They are what they are. So if you have a wheel or a disc like this spinning, I remember when I took physics, I was like, what are they saying? And it's the right hand rule. So if you have your fingers in the direction that, right, then the angular momentum vector, it shows it as coming out of the wheel this way. And I was like, what kind of voodoo are they talking about? Well, you should have watched that video before you watch this one. I had a video where that MIT physics professor had rotated that bicycle tire. No, he wasn't at MIT. He was just a physics professor from somewhere else. But he rotated that tire, and then he hung it on a rope, and it didn't flop down. It was like defying gravity, and it was standing up on its own. And then if you were to watch it long enough, it would actually go around. He didn't have it spinning for a long enough time, but it would actually spin around. That is this angular momentum in action, where a wheel turns, but it gives it a lot of stability, and it actually keeps it upright. They use, gyroscopes are used in spacecraft. In spacecraft have to point. The Hubble spacecraft has to point very precisely. Well, it has three gyroscopes. These big, massive metal discs that spin and are controlled very carefully. And then you have three of them. And so they're able to point, right? The Space Telescope, also James Webb Space Telescope has those things as well. So it's very complex, but these spinning disks, they have an angular momentum vector, right? And then with the speed and the angles, you move those. What they do is they put a torque on those spinning wheels. And then you're able to move the entire spacecraft. It's very complex. It's not intuitive. We're used to bicycles going, and we're used to, the tire stays up when you roll it. We're used to it. We don't think about it. But when you think about it, it's not really intuitive. Why doesn't gravity still pull it down, right? Well, it's this angular momentum, and it's the fact that there is indeed an angular momentum vector sticking out of the tire sideways. It's not intuitive, but it is what it is. Make sure you watch the other video of that professor spinning that tire. Think about other times when you've seen tires rotating and the stability that they have. That's because of angular momentum. Okay, folks? All right.